Okay, here we have student handout 1. This is your new unit, Basics of Transformations. Transformations are all about geometric changes of shapes that go on a coordinate plane. So let's start right here at the first bullet. To transform a shape or figure means to change it. Kind of like the Transformers, the movies. Okay, they change. In general, we can change the size, location, and direction of a figure, and direction that figure is facing. The shape or figure before the transformation is called the pre-image. The shape or figure after the transformation is called the image. So we have a pre-image and an image. And the image is the new figure. We would then label it a prime, pronounced a prime. The prime stands for this little tilde right here. Okay, this right here is a tilde. And we call it prime. And it's real important to label these when we're doing them so you know which is which. We have 4 basic types of transformations. Let's look at the first one right here. Here's your types of transformations. There's 4 of them. Our first one is a translation. Translation. Your next one is a reflection. Down here we have a rotation. And last we have a dilation. Okay, so we have 4 different types. We have a translation, reflection, rotation, and dilation. Let's look at the first picture for a translation. Okay, down here where it says keywords. Okay, up here in the word we have this SL. What a translation is, it's a slide. And that will help you remember right here, SL, that it's a slide. I'm just sliding this right here, which is my pre-image. I'm sliding it down here to quadrant 3, and that is my image. See how my image has the tilde mark on it. So pre-image, no tilde. Image has the tilde. My next one is a reflection, and we can use the FL in the word to help us remember that it's a flip. B right here is my pre-image. B prime is my image. And you'll notice I didn't just slide this guy over because this eye, if I did, this eye would be right there. So I flipped him. My next one is a rotation. And I can remember this by the T's that are in here. Okay, a rotation is a turn. And I can turn all different degrees in increments of 90. Okay, so this one, since this is my image, no, I'm sorry, pre-image. Okay, I have rotated him 90 degrees, and this is now my image. And when I say rotated, because this is a 90-degree angle right here, which we'll get into that. So you've rotated him 90 degrees. My last one is a dilation, and there's no special trick up here, but this is just something that enlarges or reduces or grows and shrinks. Okay, so I'm going to put enlarge for a keyword and reduce. Okay, you can see here that my pre-image has shrunk, and here's my image. So what I've done here in my dilation is I've multiplied all of its points or all of its vertices by a scale factor less than 1 to make it smaller, and we'll go into that later. Okay, so here's where we might see some transformations, okay? A translation, which is the slide, that can be like a conveyor belt in a factory. A reflection, this would be like the image. I'm trying to use my finger. Let's not do that. Of a landscape. On a body of water. A rotation, which is a turn. Okay, an example of something that turns is a wheel. And dilation, for growing or shrinking. An example would be like your pupils, in your eyeball. Okay, your pupils at the eye doctor. We say you're going to get your eyes dilated because they check for cataracts and stuff like that. So they go and they dilate them, and when they do that, they check to see if your pupils are shrinking or enlarging. So pupils at the eye doctor. Oh, and next page. Okay, so here's something that's pretty important. It's called congruency and orientation. Okay, and we want to pay attention to these. Congruence refers to whether or not a figure has the same size and shape after a transformation. Orientation of the figure refers to whether or not the figure is facing the same direction on the coordinate plane after the transformation. So orientation, I'm just looking to see if that figure has moved in any sort of way. Has it flipped over? Did I slide it? Did I turn it? Okay, that's what orientation is. So if I've moved it, I've changed its orientation. Congruence means I've actually changed the size of the shape. There's only one transformation that will change the size of the shape, and those are your dilations. All the other ones, you change their orientation. Orientation of the vertices refers to the order in which the vertices are labeled, clockwise or counterclockwise. Okay, so let's look at the first transformation. Transformation 1, and try to figure out what it is. You can see that here's your original image because there's no tilde marks. Here's all your tilde marks, so that's your image. This is your pre-image. And you're trying to figure out what happened here, okay? I didn't just slide it because everything would be in the same order. But now the vertice of A is flipped over to this vertice, so I have flipped it. So you have to think about the size. It's the same. So that means it has preserved congruency. Orientation of the figure. The figure is moved, okay? So my orientation has changed. The orientation of the vertices, they've moved. Okay, A used to be over here, now we flipped it and it's on this side. So those have changed. So if I ask you about orientation or congruency of the shape, here you would say the orientation changed, but the congruency stayed the same. It's still the same shape, same size. So this right here is going to be a reflection, a flip. Okay, this transformation. First, look at your pre-image, which is right here. Pre-image. And this is your image. And you need to look at and see what happened, okay? B is still in the same spot. My A's are in the same spot. My C's are in the same spot. So what I've done here is I've just slided this shape over. So that makes it a translation. So what about my size? It has preserved congruency, so the size is the same. Orientation. Okay, my shape has, or my shape is still the same. I haven't flipped it or rotated it, so now it's in a different direction. Okay, my A is still the same as this, in the same spot. My B is in the same spot, my C and my C. So the orientation of the figure is the same. The orientation of my vertices, they're all in the same spot. Okay, here's my next transformation. These are the easiest to recognize because obviously the size has changed. Here's my image. I'm sorry, pre-image. Here's my image. B, B prime. You can tell that it has shrunk. So this is a dilation. Dilations are the only one that are going to have a change in size. So for my size, it has changed. Okay, the orientation of the figure, it's all my vertices are still in the same spot. Okay, so it is the same. Orientation of vertices, same. Here's my next one. Okay, my last one, here's my pre-image and my image. My B is now down here, okay? And the only way to get it on the bottom is I have to flip it. So this is turn it, okay? I've started here at A, and I've turned it this direction, okay? To make it be right here. So this is a rotation. So the size is still the same size. My orientation, that has changed. The vertices aren't in the same spot anymore. And then the orientation of the vertices. I'm going to say that they go from here to here. They change. Okay. Real quick, summarize it. You have 4 types of transformations. Okay, write them down. 1, 2, 3, 4. Okay. Then I want you to think about the difference of orientation versus congruency. Okay. Congruency, this is a shape size change. It's either gotten larger or smaller. Okay. Orientation, I've just changed the direction it was facing. Okay, that's it. Move on to your homework.